Hey, what's up, guys? Um, Starting this week, after the break of Christmas, we're going to be talking about 4.5 performing function operations. Um, what this means pretty much is what we're going to be doing today is we're going to take two functions and we're going to add, subtract, multiply, and divide two functions. We're going to learn how we could do that. So let's define what that looks like. So if I have two functions f and g, and if I were to add them, it would look like this. The definition would look like this, or you could say the equation looks something like this. I could write it as, for example, if I were to take f and g and add them together, then while f of x and g of x looks like that, right? If I do f of x plus g of x, it also can be written as f plus g of x. Or I can do f minus g of x, which would be f of x minus g of x, and they are the same thing. And so on and so forth. Now, on this right column, we have some examples. So, if I take 5x, which is f of x, and g of x, which is x plus 2, these are two linear functions, right? Okay, so if I add them together, all I have to do is take 5x and x plus 2, add them together to get this. Now we'll go over examples a little bit more in detail in just a second, but first I want to talk about what the domain means when we're when we're performing operation of functions. So let's say that we have, so we know domain talks about the x values. The domain is trying to describe the values of x for which the function exists upon or over. So right here we have 5x, and we said that 5x is a linear function, and x plus 2 is also linear functions. Now the domain for linear functions is all real numbers. It exists over all x values. So if you were to add them together, f and g, well, because both of their domains are the same, then when you add them together, their domain will still consist of that. But let's say, for example, if you had a function like a square root function, and let's say that we were to add it to a linear function. Now, the domain for this linear function is all real numbers. But the domain for the square root function is x has to be greater than or equal to 0, because for y equals the square root of x, you can't have any x value that's less than 0, or else you get the square root of a negative number, and we don't want that. So these are the domains. Now let's say that we added these two functions together. The domain has to be consistent with both of the domains of the original functions. So in other words, how you could write this a little bit more officially is you can say that the domains of the operations consist of the x values that are in the domains of both f and g. So basically what I'm saying is that you have to take into account both domains. So if we were to add these two together, well, the domain would have to still be x is greater than 0. Even though this is all real numbers, one of the functions states that x has to be greater than or equal to 0. Okay. Now there's one more thing additionally with domain that we need to take note of, and that's whenever we use the operation of division. We'll still follow the same guidelines for the other ones that we just stated, But also, excuse me, but also, we have to consider what happens when we create a fraction. So for this example right here, f of x is equal to 5x and g of x is equal to x plus 2. Now again, we already stated that the domain for both of these is all real numbers. However, when you take f of g, f divided by g, it looks like this. That means x, which could represent any numbers, could make the denominator 0. Right? So the denominator, which is x plus 2, cannot equal 0. The denominator cannot equal 0. So that would mean that x cannot equal negative 2. Because if x equals negative 2, I get negative 2 plus 2, and that's equal to 0. And we can't have a 0 in the denominator, because you can't divide by 0. So pretty much what we're saying here is that the domain of the quotient does not include x values that make the denominator zero. Okay, so any values that might make the denominator 0, so like in this example, negative 2, it can't be included in the domain. Okay, now let's go over some examples. So for example 1, I have two functions, f of x, which is equal to 3 square root of x, and I have g of x, which is equal to, let me write g of x in a different color. I have g of x, which is equal to negative 10 square root of x. And I want to find f plus g of x. Now this is as easy as it gets. All I have to do is take f of x and take f of x, which is 3 square root of x, and then plus negative 10 square root of x. Now whenever I add these together, this is just going to be 3 square root of x minus 10 square root of x, because plus and minus means you just subtract. And now I have like radicals. This is 3 times the square root of x, and this is negative 10 times the square root of x, which means I can add them. So this is equal to negative 7 square root of x. So this is what f plus g of x is equal to. Now what is the domain? So the domain for f of x, this is a square root function, so the domain here was that x has to be greater than or equal to 0. And that's the same for this one, because this is the square root of x, so x has to be greater than or equal to 0. So it follows that the domain for f plus g of x is x has to be greater than or equal to 0. Or you could say bracket 0 to infinity. And lastly, what it wants us to do is to evaluate the sum, so f plus g, when x is equal to 4. So basically all I have to do here is take f plus g, but plug in 4 for x. So f plus g was equal to negative 7 square root of x, but I'm going to plug in 4. So this is equal to negative 7 times by 2, and that's equal to negative 14. Okay. Now let's go ahead and try and subtract. So I have f of x is equivalent to 3x squared minus 2x squared plus 5. And g of x is equivalent to x cubed minus 3x squared plus 4x minus 2. And it wants us to find the difference between them, so f minus g. So if f is equal to 3x squared, well, let's just add them to, subtract them together. So f minus g of x. So let's write f of x first. So 3x squared minus 2x squared plus 5 minus g of x, and g of x is x cubed minus 3x squared plus 4x minus 2. Now I need to make sure that I write this in this order. So I could do 3x squared minus 2x plus 5, but before I add that to the second, to g of x, I have to make sure that I distribute this negative. So this is equal to 3x squared minus 2x squared plus 5, but now it's minus x cubed plus 3x squared minus 4x plus 2. Now I can combine like terms. So I can combine these two and get 2x squared. I combine this negative 2x squared, positive 3x squared, which is just going to be x squared. I only have one x, so that's minus 4x. And then 5 and 2, which would be plus 7. So this is f minus g of x. The domain, well, the domain for f of x is all real numbers because it's a polynomial, and that goes the same for g of x. So the domain for f minus g will also be all real numbers. Okay, now it wants us to solve f minus g, but when x is negative 2. So if I plug negative 2 into this function, I get 2 times negative 2 plus negative 2 squared minus 4 times by negative 2 plus 7. And this is equal to 2 times by negative 8. Sorry, that should be cubed. Don't know why I kept writing that as that. Okay. Plus 4, because negative 2 squared is 4. Minus 8, or sorry, plus 8, because negative 4 times negative 2 is 8, and plus 7. So then I have negative 16, and if I have 4 and 8, that's going to be 12 plus 7. That should be 19. So you have negative 16 plus 19, which is equal to positive 3. Okay. Now let's go ahead and multiply some functions together. So if I have f of x, which is equal to x squared, if I have g of x, which is equal to the square root of x, I want to find f times g of x. So let's take x squared and multiply it by the square root of x. Now I'm going to rewrite this to be x squared times by x to the 1/2 power, because the square root of x is the same thing as x to the 1/2 power. Now that I have a similar base of x, and they're being multiplied together, I can use the product rule of exponents, which says that if the bases are the same, then I can simply add the exponents. So x squared, well, is the same thing as x to the 4 divided by 2. 2 is the same thing as 4 divided by 2, plus 1/2. And now I can add them together, so then I have x to the 5 divided by 2, and this is f times g of x. For the domain, for f of x, it was all real numbers. For g of x, x has to be greater than or equal to 0. So the domain is x is greater than or equal to 0. So all real positive numbers. And 0. Now, it wants us to evaluate it when x is equal to 9. So if I take f times g of x and plug in 9 for the function, so this is equal to 9 to the 5 half power. Using my rules and my properties, I can rewrite this as 9 to the 1 half power to the 5th power, and 9 to the 1 half power is the square root of 9 to the 5th power. Square root of 9 is 3, so I have 3 to the 5th power, and this is equal to 243. Alright, for this last one, let's divide the two functions. So f of x is equal to 6x, and g of x is equal to x to the 3/4 power. Now if I were to divide f divided by g of x, I get 6x divided by x to the 3/4 power. Now this 6 is being multiplied. So I'm going to write this as if it were 6 times x divided by x to the 3/4 power, and that's okay because it's being multiplied still. Now, again, I have these bases are the same. The only difference between example 4 and example 3 is that here we're dividing instead of multiplying, but this follows under the rule of quotients. So this is the same thing as 6 to the x. See, this is to the first power, so x to the 1 minus 3/4. I could subtract the exponents because we're dividing, and the basis is the same. So this is equal to 6x to the 4 divided by 4 minus 3 divided by 4. So this is equal to 6x to the 1 divided by 4. Okay. Now let's talk about the domain. The domain for the first function, f of x, this is a linear function. So this is all real numbers. However, for g of x, this is a fourth root function. This is the same thing as x to the 1/4 being cubed. So we can't take the fourth root of a negative number. So that means x has to be greater than or equal to 0. Okay? So that would have to be consistent in our domain. So x has to be greater than or equal to 0. And there's one other catch that we have to consider, and that is here, this is the function f divided by g. The denominator here cannot equal 0. So x to the 3/4 power can't be 0, which means that x cannot be 0. Because if x is 0, 0 to 3/4 power is 0. So that means that not only is x has to be greater than or equal to, but since we have a domain restriction that x cannot be 0 because it would make the denominator 0, that means x would have to be greater than 0, not equal to. It can't be equal to anymore. So that's the domain. So now, to evaluate it when x is 16, let's do f divided by g of 16, which is equal to 6 times 16 to the 1/4 power. That's equal to 6 to the 4th root of 16 if I were to rewrite it. And I know that the 4th root of 16 is 2. So this would be equal to 12. Okay, that should pretty much do it for all of this right here. And that should carry you guys into the homework. So let me know if you guys have any questions.